Okay, for question number 4A, part 1, right? They ask you to state the SPDF, electronic configuration of sodium. I think virtually people who do this particular question all got it correct. The ones that didn't get it correct is probably careless mistake. They thought that sodium is in the D block of the periodic table. It's actually found in the S block, so it will be 3S1. They ask you to then draw and label n orbital, just n, which means one orbital, from which the second electron of sodium is removed. Basically, the question here is pretty guided. The second electron, so you remove the s orbital first, that's the first electron. The second electron is removed from the p orbital. So as such, you remove from either 2px, 2py, or 2pz. Understand? X, Y, or Z. Now, what are some of the common mistakes that were made by the cohort? Number one, when you guys were presenting your answer, firstly, never draw axis. The Cartesian planes were never drawn. That's the first mistake. The second mistake is when they ask you to label the orbital, you need to state the direction, whether it's the x-axis, the y-axis, or the z-axis. So if your orbital is lying on the x-axis, please mention 2px. Lying on the y-axis, 2py, so on and so forth. With the aid of a relevant equation, so if you realize, they ask you to write the relevant equation. So what actually happened is that most of you are able to write these equations very, very well. But you know what's the mistake? Never write state symbol. Okay? Fail to write state symbol. So the state symbol are all in gaseous, and that's the main problem. Now the definition also another issue, because you only write 1 mole of gaseous ions removed. Alright? 1 mole of electrons removed from 1 mole of gaseous sodium ions. Some of you, right, you all just defined it as second IE, but you never make a reference to sodium, because the definition states what is meant by the second ionization energy of sodium. They are asking you that. Okay? I shall now move on to the next part. Now, alright, so explain why sodium has a lower first ionization energy than neon. Now, what I recommend students to do is when you are asked for ionization energy, it's recommended for you to write the electronic configuration. Then it will allow you to structure your answers better. So between sodium and neon, I do hope that you are able to see that there's one additional quantum shell. That sodium has 3 quantum shells, while neon has 2 quantum shells. So sodium has 1 additional quantum shell. So that's one bullet point. Next, what is missing in your answer, right? For those of you who got 0 marks, is you all talk about nuclear charge, you guys talk about shielding effect, but you do know that because they are in differing quantum shell, the nuclear charge and the shielding effect is basically like negating each other, like cancelling each other out. So you need to bring another factor. And the factor that you have to bring in is the distance, alright, to break the tie. Because you must understand that when we talk about ionization energy, nuclear charge is a pull factor, shielding effect is a push factor, right? So you have to bring in the third point to break the tie, which is the distance between the nucleus and the valence electron is further. Then for part 2, this one, quite a number of you got it wrong. Suggest why the pinkish glow of neon is observed before the orange glow of sodium. The reason is because you must understand that ionization energy, right guys, is all in gaseous state. When you write equations for IE, they are all assumed to be in the gaseous state. Unfortunately, sodium has a melting point of about 98 degrees Celsius. It's a solid at room temperature. So it takes a longer time because you need to overcome the metallic bonding that is present between sodium cations and the C or D localized electrons. So after we have converted this sodium solid into sodium gas, then the removal of the electron happens. Clear? So what's the purpose of this question? The purpose of this question is this. the setter is asking, right, why even though sodium has a lower first IE, it takes a longer time for sodium's color to be discharged as compared to neon. So the purpose is to highlight to you guys, the candidates, right, that ionization energy must be done in gaseous state. Correct? But unfortunately, our sodium is in solid. So it takes time, you see, for you to convert or atomize sodium solid into sodium gas. And that's the reason why there's a time lag, there's a delay. Okay? Next. Describe the reactions, if any, of the oxides Na2O and SO3 with water. So this one, I would say that for those of you who memorize, you would probably have gotten full marks. I did not accept pH 12 or 11. It is either 13 or 14. Now this one actually, if you studied Sec 3 chemistry, you would realize that the pH of the resultant solution, or this is a basic oxide. Basic oxides are metallic oxides that dissolves in water to produce sodium hydroxide. Sulfur trioxide is a non-metallic oxide, and non-metallic oxide dissolve in water to produce sulfuric acid, which is pH 1 or 2. Okay? Alright, any questions here? No, I shall move on. Now, this particular question is quite disappointing because the question was actually very, very simple. Why is it very, very simple? Because if you take a look at this here, if you read the first line, you realize that the first line not very important other than the equation. Then they say when an equimolar mixture of SO2 and O2 is passed over a catalyst at an initial pressure of 2 atmosphere. So right now, we are actually making an assumption here that this is done at constant volume, correct? So if you take a look at PV equals to nRT, right? The temperature is constant, the R is constant, the volume is constant, right? So pressure and number of moles is directly proportional. Do you all agree? Agree on this? So when someone says equimolar, that means that it's equipressure, which means that if sulfur dioxide is 1 atmosphere, oxygen is also 1 atmosphere. So 1 plus 1 equals to 2 atmospheres. So if you take a look at the initial pressure of 2 atmospheres, if you still recall, Dalton's law of partial pressure teaches us that the sum of individual partial pressures add up to give you your total pressure of the system. Correct? So when they say equimolar, it's basically equipressure. Why is it equipressure? Because pressure and number of moles are directly proportional in the conditions where volume and temperature is constant. Okay? Then they said that 98% was converted, so minus 0.98 times 1. Now this one here will be half times 0.98. Why is it half? It's because the mole ratio between sulfur dioxide and oxygen is 2:1. And then the last one will be plus 0.98. Then at the end of the reaction, you will have 0.02, the equilibrium pressure. Oxygen is 0.510, and sulfur trioxide is 0.980. Then part 2, right? They ask you to write the expression for Kb. Now, some of you wrote this particular expression in terms of square brackets, which is not accepted because when you do partial pressure, it must always be written in circular brackets. And at the same time, you must record the P for partial pressure. You cannot just simply put SO3 inside. Then you just have to sub in the respective values inside your Kp expression, and you get 4707. But by 3 sig fig, it is 4710 ATM minus 1. Now, the next part of the question, because you know that part 3, right, it was done at constant temperature, which means that big letter K is not going to get affected. Okay, I repeat, big letter K is not going to get affected. So, what happens will be, they said some sulfur dioxide gas was added to the equilibrium system to increase the partial pressure of SO2 to Y atmosphere at constant temperature. The purpose of the examiner putting this at constant temperature is to tell you that Kp is constant, which means that you need to use your answer for part 2 and bring it down to part 3. Alright, so to increase the partial pressure of SO2 to Y atmosphere, so your initial pressure will now be Y, your partial pressure of oxygen will now be 0.51. Okay? So for those of you who needs to draw graph type, so what you should do is, you should put here partial pressure as your x-axis, your y-axis rather, and then you go to the ice table previously, and then you record down, this is 0.02, this is 0.51, this is 0.980, right? So 0.02 is the lowest, so 0.02, and then 0.51 and 0.980. So you have 0.980 right at the top, and then 0.510 over here. Now, they were happily at dynamic equilibrium, so that is represented by a horizontal line like this. Then suddenly, what do? Suddenly you decided to add sulfur dioxide. So let me label this. This is sulfur dioxide, this is sulfur trioxide, this is oxygen. Then suddenly, right, you decided to add. So when you started to add, right, that is represented by a sharp rise. Understand? And it rose to what? It rose to Y atmosphere. Do you all agree now? So your ICE, your I will now be Y atmosphere. Now guys, when you add sulfur dioxide, your position of equilibrium will shift towards the right hand side. Am I right? You all agree? So therefore, it will go down for our sulfur dioxide. Our oxygen as well will shift towards the right hand side, right? And for sulfur trioxide, it will go up. So this one here will go up by 2x. Why 2x? Because the mole ratio is 1:2. This one here will go down by x because it's 2:1. This one will go down by 2x. So if you fill up your table here, alright, so this is y, this is 0.51, this is 0.98. Are you able to see that the values are the same? 0.98, 0.51 and y. Can see that? So you then sub in like this. Then after you have done that already, the next thing for you to do will then, they actually mentioned that the partial pressure of SO3 was found to be 1.5 atmosphere at the new equilibrium. So you go to your new equilibrium and you fill this up to be 1.5. Clear? So then you take the difference between these two values, then you get 0.520. But because the mole ratio is 2:1, this will be half times 0.520, and this one here will also be minus 0.520. So then this will be y minus 0.52. After that, because you are already aware that Kp never changed, you then sub in and solve for the letter y, which is 0.564. Okay? So the key ingredient to do this question is, I would suggest for you to be, if you are able to draw the graph, perhaps it will allow you to be able to see it better. Can? Okay? So just in case you are trying to find out what exactly is the value, they said sulfur trioxide went up to 1.5. So you might want to label here, this is 1.50. Okay? Alright, the next question is quite demanding. There are two parts to the question. First, why do they undergo sub? Second, why not addition? So, this 1 mark question is very, very difficult to get the 1 mark because there are two parts that you need to answer. So, now the first thing will be, what happens if he undergoes addition? If he undergoes addition, he will disrupt the pi electron cloud. Okay? Can you see that? Addition reactions will destroy the extra stability brought about by the delocalization of the pi electron. So that's the first part. Why cannot addition? Then why substitution is the second part. That's why a lot of you, if you realize, didn't get the full credit for this question. So if it undergoes substitution reaction, this destroying of the pi electron cloud doesn't happen. It retains its resonance stabilized ring system. Okay? Okay? That's why it's important, guys, when you are approaching this type of question, to circle. Alright? What is demanding? What do the questions demand you of? Okay, next up. So, the role of ALBR3, a lot of you put catalyst, well done. But the answer is not just catalyst, it is a Lewis acid catalyst. So, failure to put Lewis acid, they will mark you wrong. Then, describe the mechanism. There are a total of 4 marks. So, number 1, you have to write down the name of the mechanism first. That will entitle you to the first mark. Then, because benzene ring is not a very, very good nucleophile, I think I've already mentioned this before, so therefore you need to generate an electrophile that is capable of reacting with a very weak nucleophile. So usually something that has a positive charge. After you have done that, take a look at the arrows. The arrow must be from the ring. Alright? Not outside the ring, but from the ring, and it is being donated to the carbon atom on CH2+. After that, now, I think I've mentioned this before, the ALBR4-, right, you do not need to, you see this lone pair here? You do not need to you do not need to present this. This is not a marking point. This is a marking point. Okay? And then, guys, your slow is more important than your fast, and you need to balance. Some of you draw the product but never balance out that the ALBR3 got regenerated. So that's why out of 4 marks, a lot of you, the average score is about 2 marks. 1 mark for being able to say that this electrophilic sub, the other mark to show the generation of the electrophile. Okay?